Boom! What up, math nerds and mathletes? Coach Murphy here. Today, we are going to look at classifying 3D shapes. That's right. The guru is going to bring you into the third dimension. Pretty exciting. So, not really going to work on any problems or solving anything. We're just going to make sure that we can identify the different types of three-dimensional shapes that we're going to be looking at in future lessons. So, grab a piece of paper, a pen or a pencil. Let's get on that math grind. So like I said, classifying 3D shapes. So the first one we'll look at is a prism. Okay, and a prism is a solid with two bases that are congruent and parallel, right? And we label prisms based on what their base is, all right? So let's go ahead and get the definition of a prism here. Solid with two bases that are congruent, so it means the bases are exactly the same and they're parallel. Okay, so if we have, let's say, a triangular prism, right, that means that the base of a triangular prism, right, is a triangle. Okay, so it's basically like you took a bunch of triangles and stacked them on top of each other. Okay, so remember, a prism has the bases, either the top and bottom or the two sides are the exact same shape, right, and they're parallel and congruent. Okay, then we have pyramids, right, and the pyramids, those are solids with one base. So that's the difference between the pyramids and the prisms, is a pyramid only has one base. And the faces, or the sides, meet at one point. Okay, so you guys have all seen pyramids, right? You can have rectangular pyramids, meaning that one base is a rectangle. You can have a triangular pyramid, meaning that the base is a triangle, right? So if we had a triangular pyramid, all the sides would come up and meet at one point right there. So here's our triangular base. All the sides meet at that one point. Okay. Then we have a cylinder. I'm sure most of you know what a cylinder is. A cylinder is a prism, right? Because the bases are the same, but it's a prism with circular bases. Okay, so prism with circular bases, right? So when we talked about prisms, we said the bases were the same. They were congruent and parallel. Well, it's the same thing with a cylinder, right? Except the cylinder is going to have this circular base. It's going to go up, have another circular base, okay? With the bases being circles. I know, not the greatest picture, okay? Then we have a cone. A cone is a pyramid with a circular base. Speaking of cones, I just had a great ice cream cone yesterday. It was phenomenal. Love the cookies and cream ice cream. So, cone is a pyramid with a circular base, right? So we have our circle right down here. It comes up and it meets at one point right there, right? And then, last but not least, we have a sphere, right? This is a solid in which each point is equidistant from a center point. Okay, so think of a sphere as a three-dimensional circle almost. Okay, so when we talk about the prisms and we talk about pyramids, you're going to hear rectangular pyramids. You're going to hear triangular prisms. You're going to hear hexagonal pyramids, right? That's a pyramid that has a hexagon as the base, right? The difference, remember, the big difference when we're talking about prisms and pyramids is prisms both have the same base, and it can be turned sideways, right? Prisms only have one base, and they come up and meet at one point, right? So it's important that we know that, because the formulas, right, are going to be dependent on that. The formula is going to be dependent on identifying the type of three-dimensional figure and then identifying the base, because a lot of times we have to find the area of that base. So we need to know the area formula for different two-dimensional shapes in order to find the volume. Okay, and we'll get in that in later lessons, but I wanted to make sure that we were able to classify and know the different types of three-dimensional figures. Okay, any questions on that? They'll be addressed in later lessons. Coach Murphy out.